Hello everybody, my name is Phakhi Unnawasakul and my ID is 610-96-44424. In today's topic, we're gonna talk about transformation in graph and the way to prove the correlation of that said graph. And I may not be quite good or an expert in this subject matter, but I try my best and I hope you enjoy the video. And yeah, let's start the video. Hello again, my name is Phakhi and today we will talk about transformation in graph. As you may know, in graph the point inside the graph can transform to different coordination, form a new graph. And so today we're gonna learn how to prove that the graph have some correlation to another. So let's go to the lesson. In today transformation, I want to focus on the stuff that we need to prove, which is what we need to find. Is the graph linear together? Is it isometry? And the fixed point of it. But the important point of finding this set graph is to find the general form first. Let's go on to the examples of what we gonna do in a question. In this question 1, we have that T transform that every point move 2 points up and right. This means that from this original position, the graph moves 2 points to the right and then upward. So if we're gonna find a general form, we can use logic or either examples. In this case, I'm gonna use logic. As the question said that every point move 2 points up and right. What does that mean, up and right? That means it's gotta do with something y and x. So that means 2 points up and right. That means it's gonna have to involve with maybe x plus 2 and y plus 2 because the coordination. And then we have the general form of it, of T transformation of x, y. You have this general form. Now we're gonna try to find what we want to prove, which from that last paper we want to find the linear, the isometry, and the fixed point. Now we have the general form, we can find all three of that. Okay, let's find the linear first. By the linear we have this, the transformation of u plus v, and which is it equal to tu plus tv. Okay, now we're gonna try to find the linear one, which is are these two equals. From the last point we established that this is the general form. However, we should set up some example first, that are these two equal or not. So I'm gonna put an example here. Maybe I'm gonna imagine the point of x is 1 and y is 2 for u, and for v I'm gonna use the simple number 3 and 4 for the coordinate. And then we got we're gonna toss them into the formula we have. Mind you that this t means that it's already transformed, so we're not gonna transform them yet. We're gonna plus them together first. And as you may know, when we're plussing them, we just do them in separate segment, which means these two parts gotta plus together and the bottom part's gotta plus only the bottom part only, which we will have 3 plus 1 is 4, 4 plus 2 is 6. Okay, we have this now. We're gonna transform it, and by the transform we're gonna involve t here to here. So we're gonna put the general form inside this, which is plus 2, so we will get we'll get 6 and 8. That's the first one, and we're gonna prove this. We just got this one, we're gonna try to find this one. Okay, we gotta transform them first, and then we're gonna add them together to see whether it is the same or not. But you may know by now that if I transform this first, it would not be the same. I'll show you. Okay, we're gonna transform this. It will be 3, 4, and then this is gonna be 5, 6, and yeah, when you add them together, is much greater than the original one, so it's not equal. Then that means this does not have linear correlation. Next, we're gonna talk about isometry. Does they correlate to each other in isometry? Let's find that out. In isometry, we're gonna have this one, which is D, and what does D do is basically do this. It's create the formula for us in this form of formula. This is the general form of formula of D. So we're gonna try to find out that does this one equal to this one. If it does, it have a isometry correlation, which is it have the same distance. We're gonna put in the number that we get earlier. The general form, which is this one, in case you forgot. Okay, we're gonna put the general form inside x1, x2. That means we're gonna have to do this. x1 is plus 2 from the general form, and x2, which is also a plus form, and together square, and then y plus 2 negative 2 y plus 2. Well, as you may see, that both of them will cut them out, so that means we have 0, so it is not equal to each other, which means this doesn't correlate in isometry. Then we're gonna move to the final point, that is it correlate in fixed point. in fixed point, our goal is to determine whether this is equal to this. Well, to put it simply, we gonna compare them both to each other. So in U, we're gonna use the general form of it, which is x and y, like this. And then in transformation of U, we can use the general form that we got, which is x plus 2 and y plus 2, and then compare them. Well, as you can see now, it got no correlation to each other, even if we try to separate them to find whether it is equal or not. Either way, you got no answer. So no point in x and no point in y. So basically, in this transformation, it have no correlation, but whatever we can transform them with the general form, but have no linear correlation, isometric correlation, and fixed point. We're gonna try to move on to the next question to find the one that have something correlate to each other. Now we're moving on to the second example in today's lesson of finding transformation and the correlation to the linear, isometry, and fixed point. Okay, we have the equation with the graph showing that this transformation is by shearing, which is basically from this point if turned to this point. As you can see that the y coordinate is still saying the same height, however the x shifted. By the x shifting, we can see that something's gonna do with x, which is plus by something, and since the point is turning this way, we can assume that x plus y is the solution of this general form, or you can use example link techniques to find this exact transformation. But since we found the general form of it, we can safely say that x plus y and then y over here is the general form of these questions. We're gonna move on to the linear things. For the linear, we're gonna do the exact same things like last question by using the general form, which is x plus y and y. Okay, and then we're gonna zoom u to something and then v to something. I'm gonna use the general form of u and v, which both of them would be x and y. This is the general form. This means any number can replace this and the equation still be true. Okay, now we establish u and v. We're gonna turn them into transform form. We're gonna make this one, solve this one first. Okay, which is t u plus v equals to t of x 1 plus x 2 and then y 1 plus y 2. Okay, now we have this. We're gonna put this inside this formula. which would be, well, we're gonna transform it. The x is this one and the y is this one, so we're gonna put in x first. Now for the first x, we're gonna have x plus y, and then x plus y. This is the first one, this is the second one, and we have y. We have y number 1 and then y number 2, since maybe it's gonna be different number and all. Okay, we got the first one. Now we're gonna find the second one. Okay, let's see. I'm gonna separate it here. Okay. The thing about finding transformation is that when you got the formula right, and you start to see that most of them gonna be quite the same to each other. As you can see, x1 plus y1, and then we have y1 over here, and then we gonna have this also, which is x2 plus y2 and y2 over here. We're gonna add them together, and remember, we're gonna adding sections only, so we're gonna have x1 plus y1 plus x2 plus y2, and then y1 plus y2, and what do you know, it's the same. So we can say that this question have linear correlation to each other. We're gonna move on to isometry. Okay, now we are moving on to isometry of these questions. As you may know, the t which is distance. We're gonna try to find that both of them are equal to each other or not. Okay, as you may know, this will turn to this formula right here. Okay, this is gonna be important. Okay, now we have the formula. We're gonna place the t, which is the general form or transform form, inside this, so we can see that is it equal or not. The t from u and then the t from v. Now we gonna turn them to transform form. Plus y and then all together in square plus y2 y1 and square. Well, you can see that this gonna cut each other, and then it would not be the same as this one. So we can safely say this question does not have isometry. Now we're gonna move on to the final point, which is the fixed point, whether this graph have any fixed point. Okay, now we're at the final part of proving the correlation of the transformation. We're gonna find the fixed point of this. Let me find first this question over here, and you can see that we define the u and the transform u. The u, as you may recall, it is xy. Well, something like this, and we are trying to find that are they equal or not. Let's find that out. Okay, this is how I'm gonna turn this y, and from the general form that we found, we see that it is this x plus y, and for the y is y, so this can also be u, so that means that tu would equal to x plus y, y. So we're gonna have something a little bit like this. Equal x, y. Okay, now let's see. Is there any way that we can make them equal? And then the answer to that question is yes, we can, but in one condition. We can have a fixed point when y is equal to 0. Like this. You can see that if we turn y over here to 0, we would have only x. And if we turn both y into 0, then that means it is still y, so it is the same. So that means that this have fixed point. Yes, it have fixed point if only y is equal to 0. And that's the end of my video of talking about transformation. Let me find the paper first. Of transformations, and the conclusion to finding transformation and proving them is we're gonna find the general form of it, and then we're gonna try to prove the linear, isometry, and fixed point by using general form inside this formula. I may not be an expert in these subjects, and if I make a mistake, I hope you can forgive me, and I sincerely apologize. But if you learned anything today, I'm glad that you do so, and see you next time, maybe in the next video. So thank you for your attention. Goodbye.